And the biggest reason it takes a long time to heat up the Earth, and cool down the Earth for that matter, is that there's so much water on Earth. And water, one of the key things about water is that it has a really high specific heat capacity. So for instance, one iron atom has a specific heat capacity of 0.45 joules over grams times degrees Celsius. Whereas water has a specific heat capacity of 4.18, almost 10 times that, joules over grams times degrees Celsius. And so that means iron can heat up much quicker and cool down much quicker, and water will take much longer to heat up and much longer to cool down. I always taught my students, you can think of heat capacity as kind of like a container, and every different compound out there is like a different sized container. And the size of that container isn't necessarily based on the size of the molecule, it's based on all kinds of things like whether there's hydrogen bonds, what kind of bonding is involved, that sort of thing. We don't need to concern ourselves with that. But know that some things like water have a really big container for heat, and other things like iron or basalt and granite, the things that make up much of the Earth's crust, have a much smaller container for heat. So if you think of a desert with no water, when the sun's really hot, is that desert going to heat up quickly or slowly? It's going to heat up quickly. But when the sun goes down, that desert's also going to cool down quickly because it has a very small container for heat. So it can fill up really quick because a small container fills up really fast, but it's also going to empty really quick because a small container pours out really quick. If you think of a lake, basically it's the opposite feature. So on a really hot day, is that lake going to get boiling hot? No, it's going to heat up very, very slowly. And then likewise, when it gets cold at night, is the lake going to all of a sudden get cold? So for instance, if the lake was at 50 degrees during the day, is it going to go down to 32 at night if it's freezing? No, it's going to take much, much longer for that lake to get cold. And so water holds a lot of heat, takes a lot of heat to make it warmer, but it also takes a long time for it to give that heat up and get colder. This is what moderates the temperature on Earth, and it really is what accounts for this seasonal lag. So again, where I live in the Northern Hemisphere, it's now springtime, there's more and more sunlight each day, so the Earth should be heating up really quickly, but it isn't. It's taking a long time to heat up because the water where I live, the ocean, the rivers, the lakes, all that stuff, is still very cold from winter, and it's not holding very much heat, right? And so it's going to take a long time to fill up its container with heat and get warm.